sir. And then here I am taking the magnitude of
What was the experiment?
sir, it was to find the DFT by using formula method and then by using matrix method, then verifying it by using FFT.
Okay.
Sir, here I found the DFT, sir. Magnitude of it.
Okay, so that might have looks good to me. So have you checked? Is it coming same?
Yes,
Both
sir.
formula method and your command.
Yes, sir.
Don't give semicolon after for loop.
Yes, sir.
सेमीकलन मत दो.
Yes.
For k is equal to 1 जो उसके बाद सेमीकलन नहीं होता है.
Yes. Run the program.
Another for loop is there. There also you have mentioned semicolon.
Yes,
And
sir.
one more semicolon.
Sir, I'll remove it, sir. As all for loops are keeping semicolons, sir, so that does not get
How come how you guys are reading what is written? I can't see. Very small. It is showing to me. I cannot see what he has written.
Sir, shall I run the program?
मैं देख नहीं पा रहा हूँ. बहुत छोटा छोटा है तुम्हारा जो बोल लिखे हो. स्क्रीन बहुत छोटा है. Yeah, now it is better. So where you did this one?
Sir, this is MATLAB only, sir.
Where? Can you do it? Can you little bit enlarge?
Yes, sir.
They consume the good amount of energy which is reflected from the reflector file or reflector or
ये कहाँ पे कर रहे थे तुम? अभी जो बड़ा कर रहे थे, font बड़ा कर रहे थे.
Yes, sir.
Where you did that one?
Sir, actually, I didn't increase the font, sir. I just undocked it. Means it has opened in a separate window, sir, from MATLAB.
But still, it is okay. But still, very small. I can't read it. Very. I need to stressfully. I need to see what you have written. अगर font बड़ा कर सकते हो, then that will be useful. But anyway, Somnath sir can read it. I think he was.
Yes, I can see it.
I can't read it. Anyway, Harshvardhan, yeah, you saw the result.
Yes. Sir, what should I give input, sir? I just.
Any arbitrary input.
Yes. Sir, padding I should do or normally I should do?
Why pad?
Sir, you asked in the last class, no, sir, try padding with 0, sir.
थोड़ा जोर से बोलो, मेरा आवाज कम आ रहा है.
Sir, you asked us, no, sir, in last class to try by using padding at middle and in left side by padding zeros the sequence and check the FFT and DFT.
Yes. Yeah. You done that? Okay. You do that one also, and do the plotting. You need to see in the plot.
I'll do without padding, sir. Sir, is my plot visible, sir?
No, I can't see it.
Sir, now?
No.
Sir, I'll share once again.
I think you need to plot it in a separate window.
Sir, now is it visible, sir?
Yeah, now it is visible.
Sir, the top one I did by using the method, sir, and the bottom one I obtained by using the FFT, sir.
Okay. So it looks pretty similar, same value, right?
Yes, sir, exactly same graph I got for you.
But what is? It seems that it is just no replica. It seems that it is just a mirror image.
Yes, Like
what is
that.
the value after 13? The same it is getting repeated up to 25.
Sir, this one is sir this one no sir.
No, this one, that one is the phase.
Yes sir.
Okay, so phase, let us forget about phase. If you look at only the magnitude.
Yes sir.
Magnitude, you see, it is slowly going down, down, down up to 12. Okay, after 12, again it is getting repeated in the
Yes.
mirror image,
Yes.
isn't it? Why it is like this?
Sir, because the phase is between, sir. We can see here sir that 12 the phase is maximum. Then again we are getting here identical this thing, sir. This is
Yeah, that the same thing I'm asking. That you are saying in seeing in the phase plot. The same thing is there in the magnitude plot also.
yes sir.
Question is why it is like that? ये repeat क्यों हो रहा है? No, it is just like a mirror image. है कि नहीं?
Yes sir.
What is there in the one? N equal to 1, and that the same thing is there in n equal to 25. The amplitude is same, you see. What is n equal to 2? The same is there, n equal to 24. And what is that n? That you written n in the x-axis?
Sir, n is like time axis, sir. Discrete time axis.
What you are doing here, DFT, FFT, right? DFT.
Yes, sir.
Fourier transform, what it gives? Fourier transform provides the
frequency domain.
Frequency. है ना? तुम time कैसे बोल रहे हो?
Sir, I labeled it wrong, sir. I'll correct it.
You label it frequency. Okay, do not use the term n because it is a keyword. It is just like time, discrete time.
Yes.
Do not use that. Otherwise, your whole analysis will be wrong. Now, question is why it is mirror image after n by 2. If you see 24, 25 samples are there. So after n equal to 12, so it is getting repeated, mirror form. It's like a mirror form, isn't it? Why it is like this?
Sir, here we can see that the magnitude are different, sir, but it is decreasing in the same form, sir, because we know that the exponential signal is a periodic signal, sir, and while calculating DFT or DFT, sir, by formula method we have the exponent term in it, sir. That's why.
Where is the exponential signal? You have given just a random value, right? As input, you are not given any exponential.
Yes, sir. Input is random value, sir. So I'll get the magnitudes of the graph as random, sir. But when I am finding the DFT of this X, sir, what input sequence is, then I am multiplying an exponential term there, sir.
That's exponential term is nothing but it is sine and cosine.
Yes, sir.
Of certain frequency.
Yes.
So it will not give you a sinusoidal exponential value. It is just combination of so many sine and cosine functions, at that particular kth position, at that particular frequency. So it is not an exponential function that you are finding out. Yeah. Yes.
So I should do it before subplot, sir, after subplot.
No, wherever we are giving the plot of the frequency.
Yes, sir.
Yeah, absolute DFT, yes. After that, just make a variable of that absolute value of the DFT. Then use that variable in the FFT shift. The rest of the students, are you understanding the concept that we are discussing? Can anyone? Yes. Always put a variable. Whenever writing any command or any coding, so always the output always we keep in a variable. That is the best way of representation. Then you have to plot FFT shift.
Yes.
You're not writing in the plotting. So always FFT shift, that output where you have to plot, we have to keep it in a variable, right? When you write FFT shift, so that output of that FFT shift you need to place in the variable. Yeah, then plot that variable. But when you plot that one, but you need to change your axis also.
Sir, what I should do, sir? Is this correct, sir? FFT shift temp 0.
Yeah, that's correct. But you have to, when you plot this one, now it is shifting the mirror part to the negative axis. But how do you see that one? Until unless you represent the negative axis, तुम्हारा axis जो है, तुम्हारा axis को plot करना होगा ना उसी हिसाब से -n/2 to +n/2.
Yes.
Then mention है axis. Yeah.
-n/2 से +n/2, no, sir?
Yeah. What is the n? N is nothing but your number of frequency values. So have we taken n as the number of frequency values?
Yes, sir.
Yeah. No, you have to give n1. Yes. And change the x label as frequency, not n. Frequency bins means frequency values.
Sir, it is showing errors.
क्या दिखा रहा है? Enter 1, 2, enter 2.
Sir,
क्या लिख
x
रहा है?
must be same length as y.
हाँ?
X must be same length as y. One, sir.
क्या हुआ? Taken absolute. n-1/2 करो नेगेटिव एक्सिस में, नहीं तो तुम्हारा ज्यादा हो जाएगा ना. फिर 25 वैल्यू हो गया. -12 to +12.
Yes.
टोटल 25 वैल्यू हुआ ना.
Yes.
कौन सा प्लॉट है ये? प्रॉपर हुआ?
Yes. This one.
Why it is coming negative? फ्रीक्वेंसी तुम्हारा 350 कहाँ से आ गया? फ्रीक्वेंसी एक्सिस 350.
The frequency, no, sir. I did. this like stem absolute value
ये
of
तुम्हारा
I.
350 दिखा रहा था ना y x एक्सिस में।
Yes sir.
n का वैल्यू कितना है देखो।
Sir,
what the
मेरे
n you are taking?
सर मैंने ये क्या सर n11 मैंने माइनस n माइनस
कैपिटल n लिखे हो, कैपिटल n क्या है? कहाँ डिफाइन किए हो कैपिटल n?
सर यहाँ पर सर कैपिटल n नंबर ऑफ पॉइंट्स है सर।
Somewhere you have defined that one ना?
Sir, here this is my capital N sir, number of points.
तो ये क्या आ गया? तुम्हारा उल्टा प्लॉट कर रहे हो। प्लॉट में प्लॉटिंग जब कर रहे हो स्टेप में एक्स एक्सिस पहले रहता है, वाई एक्सिस उसके बाद, या वाई एक्सिस पहले उसके बाद एक्स एक्सिस, कैसे रहता है?
Sir, yes sir, x axis parallel.
तुम कैसे लिखे हो?
Sorry sir, x.
आया?
Yes sir.
ये दिख रहा है, डबल साइडेड स्पेक्ट्रम दिख रहा है ना?
Yes.
Now this is the actual plot. Otherwise, generally we plot from 0 to n by 2. Okay.
Yes sir.
So that's the thing. So this way you have to represent. Yeah. Now you go on putting its adding zeros.
Yes. 1 second. 1 second.
सुमना जी आज क्या करने वाले हैं एक्सपेरिमेंट?
आज ये सर्कुलर कन्वोल्यूशन।
Okay. So then after this you start.
Okay.
छोटा सा एक्सरसाइज कर लेने के बाद.
Okay. Now let him show that part that we are taking.
The maximum signal is being. That the only part that polarizing angle is higher. Other way around of engineering or it's a technical efficient way. What they do, they do that stepper motor kind of arrangement on pursue that pattern or implement the
तुम सिग्नल को पहले डिफाइन कर दिए, बार-बार ये सिग्नल को दे रहे हो।
Sir, 1 second.
हाँ, x equal to 1 to 25 कर दो।
And you also define the n point DFT, that n value of n. Okay. Let keep n is equal to 50 and signal sequence 25. Capital N 50. Then you add zero padding. Then you should show the results without zero padding and with zero padding.
Sir, actually I wrote the program such a way that we can input all the things, sir, and padding also we can input here, sir.
Okay, so for this you show the result for both the sequence length same.
Yes.
Then and store the graph somewhere else, and then you compare the two graphs.
Okay, sir.
We can make subplot. Ankesh Raj, Ankesh, are you there?
This is for F50. So this is for DFT.
corresponds only to that, but administrative taken after one.
So what I see, Somnathji, what I
Yes.
see here, the strange behavior of the students.
Hmm.
That I can see. Oh, you keep on adding the zeros, or simply can increase the number of DFT points. Let us see what is the effect.
Yes, sir. I'm entering the sequence.
So directly in the code you mention it, just like 1 to 25 or 1 to 10, like that only.
Sir, first one is DFT using inbuilt function. Matrix. So this column of magnitude.
Yeah, got it. This is the simple thing that everybody have done. Okay, so now you need to see after adding zeros in the beginning and in the front or in the end, what is the effect on the spectrum? That was the question that has been asked in last class. Okay.
Sir, I've done till here only.
You could have done it by the time. तो अभी आंसर बताना है, अभी लाभ नहीं करना है, ठीक है?
Yes, sir.
अभी आज का लाभ हम लोग दूसरा एक्सपेरिमेंट करेंगे. आप पुराना एक्सपेरिमेंट में पूरा लाभ अगर ऐसे चलता रहेगा, देन यू विल नॉट गेट टाइम. जो असाइनमेंट दिया हुआ है उसको तुमको करके रखना है. व्हेनेवर यू आस्क, देन यू जस्ट सिंपली प्रेजेंट इट. और कहीं दिक्कत है और कुछ रॉन्ग नहीं हो पा रहा है या रॉन्ग रिजल्ट आ रहा है, देन वी आइडेंटिफाई एंड ट्राई टू रेक्टिफाई. यस. Yeah, make it a little bit large. Yes, yes. Yeah, now it is better. Yeah, that's it. That's it. Yeah, this is without padding. N equal to 30 and length of sequence also 30. Good.
Yes.
So come to the result. Go down.
So this is the result I got, sir.
Yes. Okay. All right. Then next. You can just scroll down. Yes. To go slowly. Yeah. Now what is this?
Sir, 1 second. So this here I kept less number of points, sir. My
less number of points.
Sequence is 30, sir. Like.
Yes.
Sir, my here n is 10, sir. But the length of
the FFT is 30, but we are plotting 10 first. We are 10 components.
Yes, sir.
Is it that?
Yes, sir. Here I'm showing the input, sir. I got 1 to 30 the input, and input number of points is 10, sir.
Okay. Okay.
So should I go to next one, sir?
Next one. Okay.
So here my n is 40, sir, and length of sequence is 30, sir.
N, what is N? N is your number of DFT points.
Yes, sir. Okay. And length of sequence is 30, sir, here. So this is the plot I got.
So what is the thing that you see in the first case and this case?
So this was here a little bit.
Yes.
What is the amplitude of it? Sir, here, sir, without padding my amplitude, here is sir x is 1 and y is 465, sir. Then in next case, sir, if I'm padding in left, then this is changing side, right side.
What is changing?
40, 237.799, sir. Here, if we see in the previous one, sir, in 40 we are having it below 200, sir. This is below
Amplitude.
200, sir. This point is below 200, sir. And when I'm padding at left, I got this at about 200, sir.
Yeah, that is the amplitude of the DFT points.
Yes,
right?
sir. Amplitude. Yes, sir.
Okay, so that is one. And what is the other observation?
Other observation, sir. I can go to next one, sir. The middle one, padding in the middle.
Okay, go to that.
Sir, here padding in the middle, sir. I took 1 to 30 as my sequence, sir, and the length of sequence is 30, and number of DFT points is 45, sir.
So number of DFT points is 45 means what you are changing in the code?
I'm padding in the middle, sir. This point 0 to
That means that is your signal also.
Yes, sir.
Length of the signal is changing.
Yes, sir. No, sir.
No, length of signal is changing, ना?
Yes,
30
sir.
था तो उसके बीच में 15 ऐड कर दिया zeros middle. तो सिग्नल का लेंथ ही चेंज हो गया 45 हो गया now.
Yes, sir.
Okay, and you are taking the FFT of the 45 points.
Yes.
45 point DFT, right? Okay, so if you look at the same thing here, you see all the observations, all the graphs. The nature of the graph is not changing.
Yes, sir.
Isn't it?
Sir, but the nature of phase is changing, sir. Like the graph, phase one is changing. Magnitude one is the same.
Yes. Phase will be a little bit changing. And if you look at the magnitude spectrum, the nature or the pattern of the magnitude is not changing. Okay.
Yes.
And you see more number of points, means more number of DFT points you are getting in subsequent region.
Yes.
More number of DFT points, and the spectrum is now more condensed. You can say that means more number of DFT points we are getting in a particular duration. ठीक है?
Yes.
तो 5 से 10 के बीच में पहले सपोज 3 सैंपल था, अभी 5 से 10 के बीच में ज्यादा सैंपल आ गया, ठीक है? That means it indicates the resolution.
Yes.
The resolution will be better. So how close you are getting, how close you are visualizing the samples, DFT samples, how close. Okay. So that is the observation. And if you pad the zeros in between, middle, you see the amplitude also a little bit vary. Yeah. There is the pattern getting a little bit disturbed.
Here the amplitude here is varying, sir, and the starting and ending it's same like.
That is starting ending will be same, but the pattern is almost similar. But the variation of the amplitude is here getting more disturbed rather than the other case. Okay. That you can see also. Okay, so the observation is that you are getting the resolution more and the pattern of the spectrum remains unchanged. If you add the zeros in the beginning and in the end also. Okay.
So this is my third plot, sir. Here I have padded at right side, sir.
What is that?
Here, sir, this is my third plot, sir. Here I have padded at right side, sir.
right side,
Yes.
at the end.
Yes, sir.
Okay, but here you see the pattern is smooth, but when you pad the zeros in the middle, you see that the amplitude, there is a deviation in the amplitude. It's not following a exponential exactly. There is a curve, a wave kind of structure.
Yes.
You know that because of some noisy information getting added into the components, right?
Yes, sir.
So this observation you have to mention in your lab journal also. So all the rest of the students who mark these observations and okay, so that means you are getting more number of frequency point in a specific duration. Okay, that is resolution is increasing, and second thing, there is a little bit deviation in the uh, amplitude. Okay, and that is because of some kind of noise is getting added. And same thing, but the overall structure or overall pattern remains same. So these are the some of the observations when you go on increasing or decreasing the length of the signal. Clear? Okay, so now today we'll start our next experiment. Somnath sir will explain what is circular convolution and how do you compute the circular convolution. Yeah, Somnath ji, please carry on.
Yes. You stop sharing your screen, Ashwardhan.
Yes, sir. Sir, is it okay now, sir?
Yes, yes. So what do you mean by circular convolution? Can anybody tell? And how it is originated?
Sir, circular convolution is basically like if we have a periodic convolution, sir, and both the functions which we are convolving, sir, they should be periodic, sir.
No, no, not periodic. Actually, the convolution that we have studied, it was linear convolution. Okay, the sequence was linear. Means there is a time axis. Okay, so you have the entire time axis from minus infinity to infinity. Okay, but in case of some special kind of sequence like circular sequence. Okay, so the if the convolution is done between two circular sequence, then it is called circular convolution. If the two sequences are circular, what do you mean by circular sequence? Circular sequence means it is a modulo n type of sequence. Its time axis is not minus infinity to infinity, or it is not any arbitrary one, but it is limited to certain range. Okay. So you can plot the sequence over a circle so that if you want to shift the sequence, okay, either delay or advancement, the shifting of sequence will take on the circle itself, either clockwise or anti-clockwise. If you put this, if you write the sequence on a circles, okay, so the shift of the sequence will be either clockwise or anti-clockwise depending on delay or advancement of the signal. Okay. Now, how it is originated, why it is required. So, if you probably have studied the DFT, discrete Fourier transform, okay? And also before that you have studied discrete time Fourier transform. So the discrete time Fourier transforms gives you what? The frequency domain representation of a certain discrete sequence. Okay? And in frequency domain, we get a continuous spectrum. If you remember the DTFT, okay? In the frequency domain, we get continuous spectrum. Spectrum is continuous, it is not discrete. Okay? And the frequency range was from minus infinity to plus infinity. Okay, minus infinity to plus infinity over all this continuous range, and it was also periodic. Okay, so if you can remember that if you take some the time domain sequence, that's a discrete time sequence, if it is non-periodic, aperiodic signal. If it is aperiodic signal, means having some fixed values over finite length, not it is repeating, not it is periodic. If it is periodic, then it will be discrete Fourier series. If you take the Fourier transform, it will be discrete Fourier series. But if it is aperiodic, then it is discrete time Fourier transform. And its spectrum tells you that it is a continuous and periodic signal. Okay, continuous and periodic, but it is not discretized. So from that output of DFT, what we have done, that we took some samples over one period. The period was from 0 to 2 pi. Okay, or if you remember that frequency, digital frequency range from minus pi to pi or 0 to 2 pi. Okay. Over this frequency range 0 to 2 pi of the DTFT spectrum, we sampled it at n number of discrete points. Okay, over the period 2 pi, we did sampling, okay, of some particular frequencies, okay, at n number of points. So we got 2 pi by n number of frequency components over that. Now, if you get the samples, that n number of samples over 2 pi frequency range, that represents you one spectrum, okay, in frequency domain. Now, if you revert back to the time domain from that sampled spectrum, okay, then you will see some kind of sequence. Now, once that, so what in some what I told, again I am repeating, the DFT output, DTFT output is a continuous and periodic spectrum. We take one period of 2 pi and take the samples of n number of points. So we get the sample versions, okay, of that. Now that gives you the n point DFT, okay, n point DFT from the samples of the DTFT spectrum. So that's why DTFT frequencies range that you could, if you remember that it is summation n is equal to 0 to n, okay, that due to that 0 to n minus 1, due to that n number of points are considered. Now, if you revert back from those samples of frequency domain into time domain, you will see that it gives you one periodic sequence. Although you took one aperiodic sequence in time domain and did discrete time Fourier transform, it gave you the periodic and continuous spectrum, and again you sample it, the continuous periodic spectrum. Then after sampling, if you do the inverse Fourier transform or inverse discrete Fourier transform, it will give you one time domain sequence, okay, that is actually a periodic. We started with aperiodic signal, now we get one periodic and discrete signal. Now that periodic signal actually it is repeating same sequence, okay, over one cycle. Okay, if you just consider the samples, that samples are repeating because these are periodic. So that sequence is uh, actually also a linear sequence, because time axis is this is minus infinity to infinity. Okay, but if you can project the samples of one cycle on a circle, itself, okay, of one period, the samples of one period over a circle, then it will be represented as a circular sequence. So that was the origin, origin of, or the that was the basic concept from where the circular sequence came. So if you take two such circular sequence, and if you perform DFT of those circular sequence, let us say, again you perform DFT of those two circular sequence, then if you multiply those two DFT, okay, those DFT of those two circular sequence, if you multiply the DFTs of those two circular sequence, then it will give you the circular convolution. You know that multiplication in frequency domain, okay, is equivalent to the convolution in time domain. Multiplication in frequency domain gives you the convolution in time domain. So multiplication of two DFTs gives you the convolution, but it is circular convolution, because the original signal is coming from a circular sequence. Okay? So hope you have recalled this. Now I am going to the manual that was once again prepared by one of your senior. That time it was taught. Okay. Is it visible?
Yes.
Okay. So what we write here, that we take two sequence x1n and x2n. Okay. Then the formula we have, that circular convolution between two sequence x1n and x2n. So according to the convolution formula, that xn of h k minus n, that was your earlier, if you can remember, that the convolution between xn and hn, actually what, xk h of n minus k, xk h of n minus k summation is there. Now it is same, but the this sequence x to n, if it is written in this format, that x to m minus n over some bracket, double bracket, and that represents you the modulo n. Okay, because we shift the sequence. Okay, we shift the sequence over the fixed numbers of samples, over the n number of samples. Okay, so here the basic difference between linear and circular convolution is that circular convolution involves folding and shifting operations, which are performed in a circular fashion by computing the index of one of the sequences modulo n. Okay, so you just go through this manual. Okay, I will upload it. But there are two methods to calculate, okay, the the circular convolution. One is graphical method. Okay. Graphical method is simply, I also discussed in the theory, that two sequence x1n is this one, 1 minus 1 minus 2 3 minus 1, and x2n is 1 2 3. These are the two sequence. Now both of the two sequence should be made same. Okay. Length of the sequence should be made same, so we do zero padding at the end. Now what is the graphical method? That this is the graphical method. You can see that there are two sequence, 1 minus 1 minus 2 3 minus 1, and another sequence 1 2 3 0 0. This should be written over two circles. Okay. So inner circle is what? That is the first sequence. Okay. Of which that is, we are not x1 the outer circle x1. Okay. x1 is 1 minus 1 2 3 minus 1. Okay. That is written anti-clockwise. The time sequence is x1 0, x1 1, x1 2, x1 3, x1 4. This is the anti-clockwise. The time axis are changing, and similarly the sequence x2, okay, x2n, because say for first value of output y n, that is n is equal to m is equal to 0. So in that case it would be x2 of minus n, x2 of minus n. So that means it will be reversed. Okay, that is time axis should be reversed, folded. So for that, the sequence should be plotted clockwise. Okay? Clockwise. So x2n is x2 of minus n is written clockwise. 1 2 3 1 2 3 0 0. These are the clockwise sequence written. Now this is the first value at n m is equal to 0. So it is. Now, once you have written these values over the circles, then you directly multiply those and then add. So 1 into 1, then 0 into minus 1, 0 into 2, 3 into 3, 2 into minus 1. So like that you will get the value 8. Okay. Then for the second sample, that is m is equal to 1. Okay. Your x1 is not changing, okay, but x2 will change. Okay, that's why the circle is the double bracket or modulo n written over the samples, over the sequence x2, because that is subject to be shifted. Okay, so x2 1 minus n is the next one. So x2 minus n should be shifted like this, that it is now clockwise, minus n plus 1. Okay, minus n plus 1. So it is the rule is that if the positive shift, in that case it is again anti-clockwise. So it is x2 0 is then one will go, the one was there is this side, now one will go this side. So 1 2 3 0 0, like that we will get 1 2 3 0 0. Then like that you have to plot. Then again you multiply the corresponding terms. Okay, multiply the corresponding terms. So 2 into 1, 1 into minus 1. Okay, so this way, if you multiply and then add, then you will get the value. So this way, it is done graphically to calculate this convolution is calculated. Okay, then for each value of outputs, you have to calculate and plot. So this thing you have to write in your manual. Okay, I will upload this. And another method is matrix method. Okay. In matrix method, the sequence that it is under shifting, okay, that should where the shifting should be applied. Okay. The sequence where shifting that x2 modulo n, okay, x2 modulo n. So this 1 2 3 0 0 first you have to make one matrix. Okay, you have to make one matrix, and the first column would be just written as the original sequence 1 2 3 0 0. The next column it is slightly shifted, okay, 0 1 2 3 0. Okay. Then it will be once more shifted in the third column like this 0 0 1 2 3, then 3 0 0 1 2, then 2 3 0 0 1. So you have some command, you can use the MATLAB internal command, that is shark shift. Shark shift command is there. You can perform this matrix from this one. Okay, and also you note down that how the circular shifting operation is done over modulo n. Okay, because whatever the sequence, time sequence is there, okay, it is fixed. It is time sequence. Let us say it is from n is equal to 0 to n is equal to 5. So when you apply shifting by 1 unit, okay, then after shifting the sequence which is being coming to the initial position. So this 0 goes at the beginning, okay, then next 0 goes again at the beginning. So it is actually called modulo n operation. Okay, so once you get this matrix and your original matrix is B is same, that is your x1n, okay, so you just multiply these two matrices, okay, A and B, then you will get the circular convolution directly. Okay, so I'll show the programs how it is done. That write a program to find the circular convolution of two given sequence using the formula, using formula method. Okay, that means graphical method you have to use, and another you have to use matrix method. So using formula method, so first you have write the two sequence x1 and x2. Okay, then you calculate the length of the two sequence. Okay, then you find out the minimum and maximum values, okay, of the two lengths. Okay, and accordingly this is required for zero padding. Okay, wherever it is lesser, there you have to implement zero padding. Wherever is higher, then you have to ignore that. So zero padding is done first. Okay, then you have to write the, I am not explaining the zero padding part. Okay, then I am writing the coding. It is coding is written as simple as the coding of convolution. Okay, so this way it is done of the convolution program. Okay, so now you have to do it. Now here, what is circular, the matrix method? Matrix method is just you use the same zero padding is needed. Okay, and after zero padding you have to use and also this should be converted into column matrix. One matrix, since two matrix should be multiplied, so there are circular shift operations should be used, that each time it is being shifted. Okay, each time it is being shifted for each column. So, and how many columns should be generated, how many circular shifting should be performed, how many columns should be generated in the matrix, that you have to decide. So here they have simply done by creating four columns. Okay, x3, x4, 5, 4 column extra additional. But that is not at the ideal way. It is not the ideal way. The program will automatically calculate. Okay, depending on the requirement, it will automatically calculate or perform the operations in the number, how many times the circular shift will be done, and how many order of the matrix will be generated. So the program will be such that it will automatically do all the things. Now once you get these two matrices, okay, A and B, that we have discussed, then you multiply those two matrices A and B and write the result, okay, that invert, that reverse, they take the transpose y dash, it will come in a row sequence and it will get you the result. So have you understood what it is discussed and why, what is to be done? Have you understood it?
Yes, sir.
Okay, so then start doing this program. Okay, I am just uploading it. Anything you want to discuss? First you do zero padding. Okay, you don't know which sequence will have what length, so accordingly you have to write the program. Okay, one sequence may be having length more than the other or lesser than the other, so that depends on what inputs you are giving. It may be random. Okay, so so two methods you have to adopt. One is circuit, this method, okay, graphical method, or using theoretically you have to calculate, and another is using matrix you have to calculate. So two methods, one is formula method, a theoretical method, another is matrix method. Okay, so I have uploaded it. Can you see it?
Yes.
Okay, so start doing programming. Okay, start writing programming here, and we are here for